So the textbook is about ESP32 CAM, which is a dual-core microcontroller. Has been super popular. If you are still programming Arduinos and Raspberry Pis, please stop and start programming ESP32s. So yes, ESP32, we have a couple of projects that are using the ESP32 regular modules. I think starting from here and here, and also which one? So two sections are regarding ESP32 modules. And this is a special ESP32 module. It's the same CPU, but with a camera on it. So that's why it's super fun. The textbook is an ebook. You can buy online, I think 20 to 30 bucks, just buy it. Did you buy it? Yes? Good. And the good thing for the textbook is, so there are pros and cons, right? So it's not really theoretically deep into the image processing and all these theories, but it's very repeatable. So all the examples they provided online, I have repeated 80% of them. The other 20%, probably only one example had a little bug in it, but for all the other ones, works really well. Well, it's just to make some modification to the code and make it work for our purposes. Okay. So time of the class, this time, 2:30 to 3:25, Monday, Wednesday, Friday. Office hours, Monday, Wednesday, Friday in the morning. Okay. And it's going to be remote, but if you want to visit, I will open this Microsoft Teams software in my office. I will sit there, physically be there for 99% of the time during the office hour. And if you want to visit, I think feel free to do that. I think all the other professors are allowing students to come into the office area compared to last year. They are not allowed, but now you can do that. If you have questions, you can come over. I can probably check your circuits and debug something for you. Or you can just do it remotely, which is also fine. That's the schedule for all the experiments. Textbook, that's the one we are going to use for the first 4 weeks. But after that, all these materials are available on my website. Okay? Just follow the tutorials like you did in my microcontroller class. So you didn't, but you know how to follow the tutorials. I have everything posted online. Okay. That's another important reference. We only use 2 different types of microcontrollers this semester. ESP32, highly recommended, and we do have a lot of tutorials that are using that one. And also the AVR at Mega 32, at Mega 32 pins, no, 28 pins. God, I just forgot. How many pins? At Mega Arduino, just Arduino. I don't want to say Arduino, it just sounds like anyway, huh? Is that 38? 28? I forgot. So we're going to use that one, and you'll be asked to design a barebone PCB using that chip, right? Use the oscillator and caps instead of using these development boards. And you are going to fabricate, so expect to make 2 PCBs, printed circuit boards, not 1, 2, okay, this class 2, since you paid the course fee, right? 72 bucks, is that 72 or 97? I forgot. And for most of the parts, you can directly, I mean, if you build it, the PCBs, if you build the PCB and solder the PCB, you can own it, okay? 2 PCBs. The first one is for the robot car, the ESP32 CAM, And the second one is the balancing robot. So you follow these tutorials for the ESP32 cam, pretty simple, or you can say entry-level tutorials. And you can even make a surveillance camera out of it. And you know, this module is only $10. And you can literally make something at home for just $10 or $15. And there's one experiment which you can 3D print a box and put the camera inside. It's low power, right? It's not consuming a lot of power like your AC at home. So just turn it on, 3.3 volts. 5 volts being regulated to 3.3 volts. And whenever you want to check something, just connect to it and let it take a shot and send you the email or the picture. So where you can find this to be useful. For example, okay, I just found out this is useful, you know, after lunch today, actually, since my wife has been, you know, sometimes I forgot to turn off the stove and then left. So I think it's super, super necessary to put an ESP32 cam somewhere above, probably on the ceiling, you know, just, you know, I can take a picture of it whenever she's not at home. I just, you know, get an email of the photo so I can tell if it's on or off, okay? And, you know, you can find a lot of other applications, definitely, surveillance cameras everywhere. If it's mounted to a robot, then it is able to perform some really dangerous tasks for the military. Right? You can remote control the robot to get into somewhere, can take videos and photos. So follow these tutorials, and the third one will get you into a robot car with a antenna. So this will be controlled by the phone. Yeah, let me just show you here. I guess it's clear, more clear. This is a circuit one robot. I can keep using this old one. Works. Right? They have a battery, level battery cells. 3.7 volts for each, the full way 7.4 volts. So if you do anything lower than 7.4, like 7.2, 7.1, you're shut down. Very sensitive. So 7.4 is the lowest you can use. Ideally, you want to use 3 level cells. So keep in mind, always 3.7 volts for each. Then this motor driver, if that's 3 cells, I do have 3 battery cell cartridges you can use. And that's why you line them up in there. And so 3 times 3.7, what is that? Quick question. Which is a perfect voltage for this driver. And it's going to run really heavily, you know, whenever it's 11.1 volts. But 7.4 still works. And this driver controls the 2 motors at the bottom. And it receives the signal on and off from ESP32 cam. So here's the ESP32 cam. It does have a PCB antenna printed on the board. But that one is super low, so you cannot actually stream videos smoothly. So you have to use this head. Huge antenna. You have to use a drill to drill a hole on the board and mount it to the board. And you can stream videos smoothly in real time. Here is a multi-regulator, and whatever the voltage here is 7.4 volts in regulated tool. You have done this in number 4. So this is just one you can buy online instead of just making everything yourself. So I bought a lot of these modules. 7.4 being fed into this module and giving 5 volts. And 5 volts is being used for the power supply for the ESP32 cam. I have to solder all the wires on the back. Because no one can do this instead of you. You have to do it yourself. So this car, like, to be functioning, and you need to do a demonstration to me at the end of the 3rd week. This class is pretty intense. The third week, you need to start everything and make it work. The fourth week, the PCB is due, number 5. Unless you fabricate your PCB, the first PCB in this class. And after like 4 to 5 weeks, you are going to fabricate another one for the balancing car. It's more complicated. Do that. Think so? Have some kind of concept of the scope of this class. You are making PCBs, you are building robots. Let's see how this works. God, this stopped working again because it's keep changing the IP address. So it's good to show you what's going on here. All right. So see this thing. You have to have an option here because there's a GPIO code IO0. You have to short it to ground. So you want to design a 3-pin header here. So this is a female header. And if you solder the 2 terminals together, you are making a little jumper header. So you can short something together. See here, I just shorted these 2 points. You can flip it and then short these 2 pins so you can enter the programming mode. And that's the 3 pins to program it. So whenever you are soldering everything on this prototype PCB, you have to have the programming pins available. Okay, so you can reprogram it. For example, right now, the router here in this room is assigning a different IP address. I cannot open the browser. I have to reprogram. So with this FTTI cable, I just need to remember the different colors so you can make them in the correct order. It's yellow, orange, and black. Now I'm going to plug in this guy to here. Then to the USB or the laptop or desktop. And then open Arduino. Oh, I don't have to program it actually. I just need to know the IP address. I want to put it back. So I just need to turn it on and then turn on the monitor. Just making the connection. So that is the IP address, which is correct. So let me try it again, see if that works. Okay. control it. Use your phone. Okay. Right. Is that because it's connection is slow or it's too far away? Sure. Yeah, you just need to make it work in the same way like this one. That's for the first series and the fourth week PCB. Are you using Eagle? Are you using Eagle? No, Wi-Fi. Yeah, let me explain that. Eagle. Oh, Eagle, yes. Yes. Sorry. Yes. ESP32 module has a Wi-Fi controller, so it is able to connect to the Wi-Fi. So the ESP module is being served as a web server. So it's connecting, since you are coding that Wi-Fi credentials in it, so it is able to connect to the Wi-Fi signal in the building, and then it's serving as a server. So whenever your phone is also connected to the Wi-Fi, and you can browse that address of the server in browser, which is like the one that shows you like 10.18.10.16a or something. So you can log into the web server of the ESP32 module, so you can control it over there. Yeah, just follow the tutorial. It's totally doable. That's the first 4 weeks. And then we're going to cover power supply. It's going to be lectures with calculation and homework assignments. Not just power supply PCB like what we did in microcontrollers. It's going to be from AC to DC. All these rectifiers, how to calculate it, their efficiency, and everything. AC to DC, even DC to DC. And then October the 1st, break, mini break, no class. And then we're going to do the slides, lectures for these introductions of the sensor and actuators, being available for all the robots and on the market. So we're pretty much going to cover all the most popular sensors available. So whenever you are doing your senior sum or working on a project in the company, you know what are these sensors available on this planet, so you can make a choice. And we just use a smartphone, connect to Wi-Fi and control the robot, but also there are some robots from Walmart are using remote controllers, right? Like joysticks or something. So I'm going to show you how to use joysticks, how to use joysticks to control a robot. So I'm going to start with the joysticks. What's the signal being received by joysticks? It's actually a potentiometer. Give you four directions of values of the resistance and being digitized by the analog pins. And we're going to use a wireless controller because you cannot sell a toy like remote controlled car toy for Walmart which has a wire on it. So a child has to follow it instead of like the wire is going to be stretched. So it has to be wireless. And there's so many options you can do it wireless way, but we're going to use this one. It's a wireless to serial converter. So you guys can practice on using a software serial port to make that communication. So these two modules, one is connect to the joystick, definitely with the microcontroller, since you need a brain. Not you need, the system need a brain. The joystick need a brain. Joystick is nothing but a potentiometer. And it does need a brain, which is a microcontroller, to send the signal digitally through this TX-RX and then transmit it to this receiver. And the receiver receive it, process it, and then actuate the stepper motor. Can be a stepper motor, can be anything. If you can receive the value in the correct way, and how to convert the numbers, because all the data being sent are characters, you want to convert into integers and all this kind of thing. How to deal with it. It's a 24 gigahertz transceiver. And what's going to happen is you have these two modules being talking with each other. So definitely find your individual room, find a private space, since all the sensors are going to talk with each other. And you guys are controlling these, so it's going to interfere with each other. So just find a separate room somewhere else. Okay? Be apart from each other. And transmitter, receiver, joystick. And have a stepper motor on it. So you can, if you move the joystick, it's going to control this stepper motor rotating clockwise, counterclockwise. Right? You can imagine if you have this motor mounted to a car, you can control the car remotely using this little joystick. Okay, so you understand how joysticks works. This is an analog joystick. There are some products on the market which are digital joysticks. So it's actually just have more integrated circuits inside. Whenever you are moving it, you have to part it up because it's digital, right? It's not a passive component. This one is nothing but a resistor array. Okay, but if you are using something else, you have to part it up. It's going to be a active component. So the digital joysticks are directly sending digital signals. The problem can be for the modules like ESP32 CAM, it doesn't have that many GPIO available. So it's going to be a problem. If you are occupying more digital GPIOs, it has to be communicated in a digital way. Have a standard, it can be a standard, it can be a software version. Anyway, it has to be a digital communication. But ESP32 doesn't have that many GPIOs available, because you can imagine it's most of the pins are already being occupied by what? By the camera. All right, so it's receiving is super busy communicating with the camera to receiving all the pixels and process it. It doesn't have that many GPIO pins available anymore. So for this kind of thing, if you still want to use a digital GPIO, what's the choice? If you have to use a lot of other sensors, not just these joystick, but all the other different ones, but not too many GPIO pins available, what can you do? Usually, you just need more microcontrollers, right? Just add more. It's taking a lot of space in your system, but not too many choices.
Okay, this demonstration is to show you that it is able.
A quick demonstration.
Okay. So all of these
joystick controlled stepper motor
controlled by this joystick and wirelessly to this transceiver. All right. Thanks for watching.
I just mute it since I'm going to cringe if I'm hearing myself. So anyway, so that's joysticks and RFIDs. You know how the RFIDs works? You're using that every day. It has a microcontroller inside. I can't believe that. The little card, like super low cost. It has a digital chip inside. Whenever you put it close to the reader, it's going to send the wireless signal. That signal can part it up. So your card is being part up. Just converting that AC It's not signal, the AC power, magnetic field into DC voltage and then part it up. So whatever chip inside the card, it can be the card for hotel and your key card for school. So that one being powered up by the little DC voltage inside the chip, and then send that digital signal through the wireless communication protocol, anything, but it's going to be powered up and send that pulses. And that pulse is being received by the card and give a certain response regarding that. So we are going to do a very simple project by using RFIDs so you can understand what's going on for this type of everyday technology. Getting smarter every day, so you can explain to other people what's going on, right? This is the RFID reader card, and build a little system. Whenever the card is being read and recognized, it's going to rotate this servo motor. And only when that card has been registered, it's going to do that. Otherwise, for the other cards, it's not going to do the job. Okay, it's just like trying to simulate the real world application. So whenever the register card is being read, you can rotate a servo motor. You can do anything else. If you're rotating a servo motor, you can imagine the rotation will go is going to like pull the latch of the door and open the door. Right? It can be anything else. You swap the card and do something. Right? It's just the same. It's the same signal, same response, but you can apply that signal to all different applications, actuators. You can even swap the card and launch the nuclear bomb. Just an example, okay? But you just need the signal, right? Signal comes in, do anything. Okay. The balancing robot. Long tutorial.
All right, so this is
Purpose.
a two-wheel balancing car I just built on the breadboard.
You need to cut and make these boards in the shop and 3D print the battery holders. We don't have it here, but I have the file for you guys to directly print it out. And maybe some little parts here as well to make the connections.
Using Arduino Uno.
And yeah, that's it. And we're going to do some lectures regarding how to do the control, what's behind the scene.
The controller and
so it's just need to make it stand on the table.
Works perfect. Okay. So when you are
even
building
you
this
put some
prototype, I
load
highly
on the top.
recommend you after test everything out on the breadboard,
Like put a bottle of water on the top.
balance.
Still able to get stabilized.
Okay, no problem.
Okay, that's another one. And then foot brake, aka Thanksgiving, right? And then real-time system. Advanced microcontrollers. We didn't cover real-time system in microcontrollers, which is CE432, but I think I'm going to cover that in the future versions. So when Michael take it, probably you are going to learn that in the spring. But we'll do some similar ones here as well. It's just dealing with schedulers. Whenever you are just programming Arduinos, you can have one interrupt, you can have two interrupts, and it's pretty much it. That's it. You have multiple tasks and you need more interrupts, and you are, confusing yourself and also the one controller. So you need a scheduler to do everything by the schedule on the timeline. So this time I'm going to do this. Doesn't matter if it's not finishing this. Then I'm going to do another one after that certain time frame. So usually it's 1 millisecond in ESP32. So do one, another one, then just keep doing this after the whole cycle. So we don't have to deal with interrupts by ourselves. So it's called operating system. It's the same as your operating system in your phone, in your laptop, in your desktop, but it just has more graphical user interface, like your Windows. Right? It's actually handling a lot of interrupts. How it is able to handle that? Whenever you are playing a YouTube video, you are also, put comments on Facebook, and you are also typing something else in Word. How that works? It's all being handled by the operating system. If you don't have operating system, nothing can work like that good, right? You have to use operating system. And for real-time system, when you are programming a microcontroller, you are going to use the operating system with your microcontroller. Arduinos are, so the memories, the size of the memories in Arduinos are too small. Sometimes it's not the best candidate to apply your free RTOS. Write it down. So that's the operating system we're going to use. Real-time operating system, and it's free and super popular. If you know how to do this, you can find a job easily. Not even saying IC design. Programming your Arduinos like P mode 5, output. Okay, analog read, digital write. That's the hobbyist level. So RTOS, free RTOS level programming of microcontrollers can get you a job, $120,000, $120,000, yes, pretty much at the start. Embedded system engineers. You just do a search on Google, real-time system engineers. You can see the qualifications. It must be like have 5 years of free RTOS experience. Okay, can make you become a pro. Let me see. Anything else? Probably that's it. I was thinking that for the first tutorial, so just please note that next Monday, the first tutorial is due. So you have this week to work on this stuff. Not very long. That's it. And all the code are available. I'm not going to explain every single line for you guys since you guys are not freshmen. So if you have questions, we can talk about it, we can discuss. But otherwise, just follow and get it done. So the code are available in the textbook, pretty much. And there are some bugs, and I think I already made the correction. You can see the correction, where to make the correction to make it work. And you need to do something to the board to make it compatible with the antenna, which is here, the ESP32 cam. So do you know Burnhole 602? So Wednesday, I'm not going to be here. So all of us will be in 602. So I'll give you time to solder this little resistor to make it compatible with the antenna. I'm going to teach you how to do it. Be careful. There are some tips. So you'll probably want to follow me on how to do it. If not, you are going to damage 3 to 4 ESP CAN modules until you can get one functioning one. So that's a little resistor, super small. And you want to desolder that and then rotate it and solder to the other pad. So it's going to make the selection to the antenna being attached to this port, but not using this antenna on the PCB. So this antenna on the PCB is not working really well, super slow. And you want to use this one. You want to attach the antenna to this port. and you have to rotate the resistor. You know how to do it? So it's like this. Here's a metal pad, metal pad, metal pad. And now the resistor, you know the resistance of the resistor? 0 ohms. Just shorting these two pads. You don't like asking why 0 ohms. They just designed it. It's on the schematic. They just want to make the connection. So if you are making a wire, you can imagine that when they are trying to batch processing for the manufacturing of this board, they cannot place the wire to it. If they just have a little resistor, it's just super tiny resistor, but it's 0 ohms. It's shorting these two pads. So it's easier for fabrication. They have the big machine for PCB assembling. It just like have the robot arms, just boom, boom, just do this. They can do it together, right? It's easy. And when you are trying to desolder and resolder that, you still have something to change, right? If you have directly a wire pointing on the board, you cannot change it. You have a little resistor like a rod. So it looks like this. So now the resistor, look at whatever, just on the left side of this port, a 10-nanometer port, it's this PCB structure on the board. Okay, and now the resistor is being soldered here. Super, super small. Now, what you want to do is you want to desolder it and rotate it and solder it here. That's what you want to do on Wednesday. So, how to do it? You want to have one iron tip. You heat up here. Here's cold. You can still not desolder it. You want to do it fast. You just melt here, and then remove it. No, it's not working. You can never be fast enough to melt here and lift and melt here, and this still melted. No, it's going to become metal in less than like a tenth of a second, probably a fifth. I don't know, but very quickly. So how to do it? You just have one iron tip. How to desolder this guy has two pads. Huh? Blade? No, it's not. It's not going to work. It's a you have to replace the nozzle. It's complicated. You can do it in a very simple way. So the way to do that is make a solder droplet on the tip. So the droplets actually doesn't have to be big because the entire thing here is tiny. So have a melted solder on the tip, like a bowl. So it's melted, right? It's hot. It's attaching to the iron tip. Have that bowl directly placed on the top of everything, so the bowl is going to cover this resistor. Because the melted solder bowl is very hot, so it's going to melt these two pads at the same time. So you can remove it easily. Okay, just have the solder. So you're going to grab the solder wire and grab some with the iron and place that little hot solder bowl on the top of this resistor. It's going to cover these two pads because this is tiny. So both sides will be melted, and then remove it. Okay, and then clean it up. You have to clean it up because it's tiny. It's going to have a lot of solder on the resistor. And rotate it, and then solder to here. Be careful. This is not really easy to do it. Okay. I damaged the tool, so just let you know. You know, the reason I damaged it, why is that? Because the pads are tiny, super, super small. So the epoxy that bonds that metal layer to the PCB material is limited. So I placed my iron tip to here, try to melt it for a little bit too longer. I mean, probably 2 seconds, a little too long, 2 to 3 seconds. Then the pad on the PCB, the epoxy underneath the pad are melted. And when I lift it, so the whole pad is just came out from the board. So I lost my metal. I have nowhere to solder it. If you lost this metal, it's fine. I lost this one. So when you rotate it, you want to solder to here, it's not going to work. You don't have a connection. So the whole board is damaged just because this little epoxy is melted. Okay? Make sense? We should do it together. Okay? I know we have 8 students, so I bought 10 ESP32 cams. After I times the 2, I just bought 100. No, I'm kidding. I think I bought like 50 or something. So you pay the course fees. So we should give you guys enough number of modules to play with, right? It's not like you damage one, you have to pay it. Anyway, so on Wednesday, we are going to rotate it, solder it, attach a antenna. I have a lot of antennas. Attach a antenna to here and download the code to it. And probably the first 2 examples in the tutorial, you can start working on that on Wednesday. Okay. You just start getting everything done. So we have the whole week to work on this first tutorial. What do I expect from you guys? I expect you guys submit the. So for the first one, you don't have to really demonstrate the functionality in front of me. You're going to record videos, take pictures, and put in the report. So we have 3 tasks, 20 points, 40 points, and 40 points. So total 100 points. I don't think I asked you to demonstrate it in front of me, but if I did it in the tutorial, since it's super long, I couldn't check every paragraph right here. But just follow whatever I put in the tutorial. But I think it's going to be just report. And the way to turn in the report is still the same way as usual. You have student lab reports, have all the links. Other people are super familiar with that, since most of you are very old friends of mine. Michael is my new friend, and so I just sent you the credential to log into the website. So just follow the tutorial. If you don't know where to find the tutorial, I think here. Oh, I didn't give a link to Robotics 2, but if you can go back to find out Engineering 338 Digital Electronics, this class, this lab, and you'll see edit your web page. So you'll find out how to do it, how to upload all these HTML lab reports to the website. And after you are done with that, you'll see that your lab reports will show up here, right? Now it's just a template. You have to replace it. So we're going to change the title and give all the, the title for each entry. So each entry should be a different tutorial or different task or something. So you can place all the lab reports here. And I will open the web page of your tutorial on, let's see, by the end of Monday next week, September 6th. And I'm going to print that web page into a PDF. I'm going to grade on the PDF and send it back to you by email. Give you feedback in that way. Okay? And no plagiarism is acceptable. Okay? If you directly copy and paste someone else lab reports, and we're going to fail this class. So it happened last semester. And I know you won't, huh? Huh? Sorry? No, you don't. Oh, compared to last time? Yes. So good question. So for example, so right now I'm not creating new credentials for everyone every semester. So if you have been in my class, you're going to keep using that credential. Same for everyone else. And I just placed all the students' folders into one place on my server. So you guys are keep using that part. So for example, for Sean, okay, so he has been in my different classes, has been working with me in the lab, and so he has all different tags. You can do it in the same way. You just have a different homepage, right? You can say like Michael's homepage, and this is my robotics 2 lab reports. For example, you click this one, you can see all these digital lab reports last time. Okay. Same for John, same for Audra. If you cannot log in, just let me know. Any other questions? No? So I think we should walk to Burnhole 602 right now, and I'll give each of you a box. And I think I won't be able to find out all the parts you will need for these tutorials, but you can grab as many as you can. You can come over and grab the parts anytime you are available as well.